For this problem, we are given a cantilever truss shown, and we are tasked to solve for the reaction at E, forces in member BC and DE. To do so, we draw the free body diagram of the reactions at the supports. So at E, we have a force going vertical equals EY and EX, because E is a pin. And for this member here, we can try cutting this segment, and we expose tension. Let's call this force T. So to solve for these three unknown forces, we utilize the equations for equilibrium. So taking summation force moment at E equals 0, we can solve for the tension T, considering counterclockwise to be positive. So we have T and its vertical component, sine of 30 degrees, multiplied by the moment arm distance, that is equal to A over 2. Since it is going in the clockwise direction, it is negative. And then we have the component for T acting horizontally, that is acting clockwise. This is also negative, so this is T cosine of 30 degrees multiplied by the moment arm distance of, so since this is A and this angle right here is 60 degrees because it is an equilateral triangle, therefore the moment arm distance is equal to A times sine of 60 degrees. And then we have the forces of 74 that would induce a counterclockwise moment, so it is positive, multiplied by the moment arm distance of A, and for the 48 kilonewton force, it has a moment arm distance of 2A equal to 0. And dividing this equation by a common factor of A, we get negative T sine of 30 degrees times 1/2 minus T cosine 30 degrees times sine of 60 degrees plus 74 plus 48 times 2 equal to 0. And we can solve for T by using our calculator. This is negative T sine of 30 degrees times 1/2 or 0.5 minus T cosine of 30 degrees times sine of 60 degrees plus 74 plus 48 times 2 equal to 0. Shift solving, we get T is equal to 170 kilonewtons. Now we have the value for T. We can now take summation force vertical and horizontal to solve for the reaction at E. So let's start by solving for the reaction of EY. That is EY minus the 74 kilonewton force minus 48 plus the tensile force of 170 kilonewton sine of 30 degrees equal to 0. And we can now solve for EY. That's EY minus 74 minus 48 plus 170 sine of 30 degrees equal to 0. Shift solve, we get EY equal to 37 kilonewton. And to solve for EX, we take summation force horizontal. So EX is equal to, taking summation force vertical, we have negative EX that is going to the left plus the horizontal component for T, that is T cosine of 30 degrees equal to 0. And we can now solve for T, that is negative EX plus T with a value of 170 cosine of 30 degrees equal to 0. We get EX is equal to 147.22 kilonewtons. To solve for the net force at E, we take the square root of the sum of the squares of EX and EY. And we're just basically doing a Pythagorean theorem. So the force, net force E is equal to a square root of the components EX squared plus EY squared. That is equal to 151.79 kilonewtons, or approximately equal to 152 kilonewtons. And that's the answer for our first problem. Now that we have the value for the reactions, we can now proceed solving the force in member BC and DE. We can apply the method of sections, and this segment here, and considering left side, we expose forces BD, BC, and AC, assuming they are all in tension. So we're drawing our free body diagram. We have forces AC, force BC, and force BD. and this angular here is 60 degrees. And we have a downward force of 48 kilonewton. So to solve for BC, we take summation force of vertical equal to 0. So we have negative 48 minus BC sine of 60 degrees equal to 0. Now we can solve for BC by using our calculator. We have negative 48 minus BC sine of 60 degrees equal to 0. Shift solve, we get negative 55.43 kilonewtons. Since our result here is negative, therefore our assumption that BC is in tension is incorrect. Therefore BC must be acting in the opposite direction, which means that BC is inducing a compressive force on this joint. So the answer for the second problem, the force number BC is equal to 55.43 kilonewton, or approximately equal to 55.40. Now to solve for the force in member DE, we can utilize the method of joints by analyzing at joint E. So at joint E, we have the reactions at the support, 37 kilonewtons going upward and 147.22 kilonewtons going to the left. And we have two forces. Assuming tension, we have forces CE and the unknown force DE. And this angle right here is 60 degrees. And to solve directly for DE, we take summation force vertical equal to 0. So we have FDE sine of 60 degrees plus 37 kilonewton equal to 0. So FDE times sine of 60 degrees plus 37 equal to 0. Shift solving, we get FDE equal to 42.72 kilonewtons. Since the sign here is negative, therefore FDE is in compression. So the answer for this third problem here is approximately equal to 43 kilonewtons.